let me show you what real algebra looks like. So this is the fundamental theorem of algebra. Fundamental theorem of algebra. This is section 2.5 in the book. Fundamental theorem of algebra. The fundamental theorem of algebra involves polynomials, right? Remember, we have polynomials. We talked about polynomials before, and they are things that are like 2x squared minus 3x plus 5. Or x to the 5th power minus x to the 4th power minus x to the 3rd power minus x squared minus x plus 1. Or anything like this, right? Anything with the exponents, starting with exponents going all the way down to a number. 5x to the 3rd minus 1. Even if it skips some pieces, it is still a polynomial. So these are some examples of polynomial, right? And this is the fundamental theorem of algebra. The fundamental theorem of algebra says, fundamental theorem of algebra says the following thing. A polynomial of degree n, meaning some number, will have exactly degree n of algebra, fundamental theorem of algebra. A polynomial of degree n will have exactly n complex roots. That is the fundamental theorem of algebra. And so remember, we talked about the biggest exponents when we say degree. When we say degree, degrees are the biggest exponent. This is your degree, right? So your exponent here is your biggest exponent is the degree. The degree means the biggest exponent. So this is a degree of 2. This has a degree of 5. This has a degree of 3. Your degree is whatever the largest exponent of your equation happens to be. Okay? So the fundamental theorem of algebra says, whatever your degree is, a polynomial will have exactly that same number of complex roots. Now, when we say roots, right, there's a lot of, I told you there's a lot of words that roots have, right? Roots can be also, we can call them zeros. We also call them zeros. We also call them factors. And we also call them x-intercepts. Right? We also call them solutions. In other words, solutions. All of these words mean the same thing. All of these words mean the same thing. They mean roots. They mean zeros. They're all talking about the same feature of an equation. Okay? Same feature of an equation. And a root, what we mean by root or zero is we mean the location where it touches the x-axis. These are the roots. All of these things mean these locations here, where the graph touches the x-axis. Roots or zeros or factors, all those numbers mean these same spaces here, these roots here. This would be like A, and B, and C. And again, when we have roots, we mean the function x with these parentheses. Right? X minus A, X minus B, X minus C. Those are the zeros. The roots are these numbers in the parentheses, right? And this parenthesis here, this is a factor. And the number inside, this A, is one of your roots or solutions. Or zeros. Root slash solution slash zero. Solutions. So the fundamental theorem of algebra says that an equation, a polynomial with whatever degree n, right? Let's say n is 5, it will have exactly 5 roots, 5 factors. There will be 5 parentheses if the degree is 5. If your degree is 3, you will have 3 parentheses. If your degree is 7, you will have 7 parentheses. There are exactly the same number of roots as there is the degree of the polynomial. That is the fundamental theorem of algebra. And in order to solve this, we needed to understand what complex numbers were, right? We need to understand what a polynomial is. We need to understand how to factor. So you've been building up for this concept for a while, since like 8th grade when you started talking about parabolas. A parabola is one type of polynomial. And your parabola has 2 factors. Right? When you factor your polynomial, you factor a parabola, a quadratic equation. That quadratic equation gives you the 2 zeros, the 2 roots. Talk about quadratic formula. Talk about factoring your trinomials. All of that stuff is exactly what we're doing here. But this time we're saying, well, the power, your exponent, doesn't have to just be a 2. It could be 3, or 4, or 9, or it doesn't matter. Any exponent up here, we can figure out all these different factors. It's going to be the same number of factors as the degree. And that's the fundamental theorem of algebra. That's the bigger picture. It's the bigger picture we're looking at. So you can imagine what this means. Or we can go through some of the examples, right? If you have a linear equation, y equals 2x plus 1. Okay? Y equals 2x plus 1. Here's a linear equation. The degree of this one equals 1, right? This is like a 1 exponent. This is your linear equation. And a linear equation is going to cross the x-axis 1 time. Just say roots. right? Linear equation is going to go from bottom to top, just like we said. Linear equation is going to cross the axis one time. If you have a quadratic equation, quadratic, y equals x squared plus 3x minus 5. Quadratic equation. You're going to have an equation that looks something like this. Its degree is 2. And it's going to cross the x-axis 2 times. And you can write this equation like y equals x, minus 1 and x plus 5. Maybe, I'm going to make this a 4. 4 here. There. Now it factors nicely. All right, we're going to have negative 5, and we're going to have positive 1. And those are going to be our roots. So quadratic equations, they cross 2 times. Linear cross 1. Cubic equations are going to cross 3 times. Right? All the exponents, no matter how many exponents you have, it's going to have that many complex roots. So the thing we need to talk about, and how much time do we have? Oh, good. About 10 minutes, 15 minutes, perfect. The thing I need to talk about is there are different types of roots, right? Sometimes they cross, and sometimes they don't, and sometimes they have a double root. So we're going to get into the different types of roots. Types of roots. Okay? I'm going to talk about the different types of roots you can have. Okay? So in the first situation, what you can have are, in an equation, you can have, if it crosses the x-axis, these are 2 real roots. Real roots means it touches the x-axis. We can have 2 real roots, we can touch the x-axis. So one type of root is a real root, touches the x-axis. Another type of root is the kind that just barely touches only one spot. And this is a double root, right? We talked about that double root. Let me write it a little bit better. Double root. We call this a multiplicity. Multiplicity. And it happens when you have something like x minus 3 squared. Okay, x minus 3 squared. The multiplicity is the exponent. So this is a double root. You can have multiplicities of 3, you can have multiplicities of 4, whatever your exponent is, right, your double root. This one has 2 separate answers, a and b. This one has one answer that's like squared or cubed or something like that. It's a double root. Something happens, it only touches one time. So we can have real roots, double roots. Last thing we would have is if it doesn't touch, right? It never touches. Let me try the parabola again. If it never touches, this would be two imaginary roots. Imaginary roots. And that's if it does not touch the x-axis. Does not touch, touch the x-axis. Okay. So all the polynomials will have some combination of these three types of roots. They'll have some real, they'll have some imaginary roots, they'll have some different types of roots, right? But together, the sum total of all the different types of roots they have has to equal the degree. The sum total of all the roots they have has to equal the degree. So all polynomials, let's say all polynomials will have some combination of these roots. But the total number will always equal the degree. All polynomials, capitalize that, all polynomials will have some combination of these types of roots, but the total number of roots will always be equal to the degree. So you can have imaginary roots, you can have real roots, you can have double roots, you can have whatever type of roots you want. But the total number will always equal the degree. So here's what I'm going to have you do. Let's do an example. Okay, let's do an example. We're going to, I want to say, here's my equation, y equals x cubed plus 4x squared minus 3x plus 1. Here's an equation. Right? And I want to know what roots does this equation have? What roots does this equation have? And what we're going to do, what you're going to do is you're going to make a root table. Make a root table. And we're going to draw this little table, and we're going to sort of separate it into some categories, right? We have real roots, and we have imaginary roots. Imaginary. Now, there's another separation we need to do. In the real root category, right? What kind of roots? You can have real roots can have two kinds, right? Real roots there are actually two types. There's rational, which is like x minus 3, right? Or 1/2. You have rational roots, which are like when the graph crosses at like -3 or 1/2. And you can also have irrational roots. Irrational. Let me write that word a little bit bigger. Irrational. Irrational. Where you can have things like the square root of 3 or pi. Maybe your function crosses at pi. I don't know. So in the real category, we have these two subcategories. We're going to have rational, or irrational. Let me try to write this word a little bit better. Irrational. Okay. And so I want to predict the possibilities. I'm going to list all possible roots. List all possible combinations of the different types of roots I can have. Okay? And so I know that my total number has to equal 3, because my degree is 3 of this equation. My degree is 3, so my total number of roots has to equal 3. And I can have different combinations. I can have, for example, all 3 of my roots be rational, none irrational, and no imaginary roots. That's a possible combination. That's a possible combination for this equation. I want to list all possible combinations. My real roots, I could have all 3, right? I could have my graph cross 1, 2, 3. This could be the number 6. This could be the number 2. This could be the number 7. Right? I can cross in 3 totally regular numbers. Right? That's a possibility. Or I can cross in a different way. So a little, let's see, how do I say? One of the rules, right, about irrational and imaginary roots that's a 0. This is a 0. 0 imaginary. The rules for this table are rational can be any number. Rational can be any number. But my irrational, and my imaginary, they come in pairs. So I'm only allowed to have an even number of irrational or imaginary roots. My imaginary roots and irrational roots, they always come in pairs. So there's only 2 or 4 or 6. I have to have an even number of irrational or imaginary roots. They come in pairs because of the square root. Right? When you do a square root, you have a plus or minus. They come in pairs because there's a plus minus in front of the square root. So irrational and imaginary have to come in pairs. Rational can be any number of roots. So if I were to do another possible combination, well, I could have 2 irrational roots. How many imaginary roots can I have? What are my other possibilities? Could I have one imaginary root and no rationals? Is that a possibility? Is that a possible combination? Yes, this says rules for roots. Rules for roots. If I have two irrational roots, can I have one imaginary? No. Have to come in pairs. I can't have one imaginary. I would have to have one rational and no imaginary. Right? So you have to follow these rules and decide which combination you're going to have. I could have two imaginary. If I have two imaginary, could I have one irrational root and no rationals? Right? Well, no, I couldn't have just one of these and none of these. This is not going to work because they have to come in pairs. So my irrational is not going to be 1. My rational has to be 1 here, and there'd be 0 there. And so following these rules, right, where my irrational and imaginary come in pairs, these are the only combinations. These are the only combinations I can have for my roots. The only possible way my 3 roots can fall into these different categories are these combinations. I can have all of them be rational, and no irrational, no imaginary. I can have 2 irrational. If I have rational, that means I have no imaginary and 1 rational. Or I can have 2 imaginary, no irrational, and 1 rational root. I have to have. This is the only combinations. All this equation has to fall into one of these 3 categories. It's my possible root combination. Now, which one's correct? That's the question. And that's what we're going to talk about tomorrow. We're going to figure out how to get this, how to figure out which one of these 3 combinations is the right one. All right. So your homework tonight is to finish up the Desmos activity. If you haven't already, finish up the Desmos activity. We will go over this on Thursday. But that's it, everybody. Yes. Enjoy your lunch. I'll see you all next time. Say goodbye in the chat. Once you say goodbye, you're free to go. Enjoy your Wednesday. No homework except for the Desmos activity, correct? We will do the rest of this stuff on Thursday. Thank you all.